Hi, 6th grade. Happy Wednesday. I'm recording this video ahead of Wednesday, May 6th, and so I'm hoping that you guys were able to get me your planet project presentations and you were able to view those on Monday. If not, just hang tight. They're coming this week. I'm just waiting on all of those to be given to me from you guys. But I just wanted to remind you again from the previous video that once you have access to those videos of your classmates' presentations, that you do have to go on to ClassReach. And on your account, again, you're going to pick the discussions board. And for any three of your classmates, don't forget you have to answer these two questions. Remember, you're sharing something that you learned from watching their presentation about their planets, and then you're also praising them for something that they did a great job on in their presentation. And again, you're doing that for three different people, being sure to let us know who you're complimenting and who you learned from, all right? So don't forget, that's for this week. Work on that. Let's be encouraging to each other and build each other up with nice compliments on your projects, which I know I've already seen some of them and they came out great, guys. I'm so proud of you. They look awesome. All right, and so with that little housekeeping thing out of the way, we are going to be starting a new lesson today. This is lesson 8.1.3 on star systems. All right, so a true star system is a group of stars that influence each other gravitationally. Okay, so this has to do with the gravity of the stars. Stars that are formed close to one another are bound to each other by mutual gravitational attraction. So if the stars are formed in the stellar nurseries nearby, they end up being basically bonded to each other, although not technically together, but in the general vicinity because of gravitational attraction. And this allows them to move as one body, and this is what we call a star system. Okay, so it's a system with several stars. Many stars are part of what's called a binary star system. So if we break down the word binary, bi always means two as a prefix, okay? So a binary star system is going to be two stars or a pair of stars, which is why a binary star system is a pair of stars that orbit their common center of mass. So those two stars that make up the binary system are orbiting a common center of mass. And there is much diversity within binary star systems. Some will be so close to one another that the two stars orbit each other just in one day's time. The stars are orbiting one day's time. Others are separated by very vast, great distances, and they only orbit around each other over the course of millions of years. So that's obviously not something that we would see in our lifetime because of the length of time. But as you can see, there's great diversity. Something as short as just a day versus millions of years. Some stars are part of what's called a triple or a quadruple star system. So much like the binary system was for two stars, a triple would be for three stars and a quadruple would be for four. But they're less common than the binary star systems. A triple is the result of a binary star system trapping a single star in its orbit. So an existing binary star system with two stars ends up trapping a rogue third star out there, and they become a triple star system. And the quadruple is typically the result of two binary star systems, each with their own two stars, coming together by gravitational pull around the common center of mass. And the triple or the quadruple star systems are really unstable in comparison to the binary star systems. So, a large system of stars and its solar system, gas, and dust, all held together by gravity, is called a galaxy. And I know you guys have heard of galaxies before, but now we're actually putting a definition to that. So it's not just the planets, it's not just the stars, but it's also the gas and the dust that are all held together by gravity in that one area, and that makes up a galaxy. And God has sustained a wide variety of galaxies in all different shapes and sizes. So up until this point, maybe you thought that a galaxy was a galaxy, but there's actually many different groups of galaxies, different sizes of galaxies, and as we're going to see, there's different shapes of how galaxies are formed, and so there's much diversity in there too in God's creation. Most galaxies are found in groups, and they are so large, these groups, that scientists have to use a different means to measure them. They use something called parsecs and kiloparsecs. Parsecs is abbreviated PC, while kiloparsecs is KPC. And so a parsec is 3.26 light years in distance, and a kiloparsec is 3,260 light years, for your reference. You do not need to be able to calculate that. That's just so you understand that because of the vast size, the sheer, immense, almost incomprehensible size of galaxies, even using light years, which we know from previous lessons is another astronomical unit that's used because of large distances, even light years is not a big enough unit to cover galaxies. So they had to find a bigger means to measure it, and that's the parsec or the kiloparsec. Astronomers estimate that there are as many as 100 billion different galaxies spread throughout the heavens, so a lot, 100 billion. And larger galaxies may contain as many as trillions of stars, and smaller galaxies may only contain a few millions of stars. I mean, a few million is still a lot of stars, but that's considered pretty small for a galaxy compared to the trillions of stars in a larger galaxy. And astronomers are able to observe size, brightness, and mass, and they use those three factors to estimate the number of stars in any particular galaxy that they're studying. So, much like most of what's in space, even though astronomers have ways to assess these things, they're of course kind of just educated guesses because there's so much of the universe that we don't have access to yet, that we don't have scientists that have been able to get to those places and reach those places because God's creation is just that immense and honestly like kind of mystifying. Whether or not someday in creation scientists will get to these places, maybe, if that's part of God's plan, but there may be things about our galaxies and all the universe out there that we may never understand or see this side of heaven. And so just keeping in mind, like, all this information is best educated guess based off of what we know right now in science, but it could change. And it may not be entirely accurate. I mean, some of these galaxies could be bigger or smaller than what we thought they were. Additionally, when we study galaxies, we can study, as I said, they come in different shapes. And so there's three really main shapes. There's a couple others that, depending on the textbook you look at, will list. But the three major shapes that we find galaxies in are spiral, elliptical, and irregular. So spiral galaxies are the most common. They look something like this picture here, and you can see it makes like a very spiral-like pattern. And it has a reddish central bulge in the middle, right here. And that's composed of older, cooler stars. Remember, blue is really hot, while the red is actually a cooler star when we're looking at the spectrum and the luminosity and brightness of stars. Revolving around the center of this bulge are bluish arms. Okay, so these kind of look like arms. They're calling them arms, but these extensions here off, these bluish arms, bulge off the center, and those are composed of hot stars. Something about spiral galaxies is that they do contain the nebula, okay, as well as lots of gas and dust. And as we're going to see as we look at the other two shapes, some of this is not true of the other two galaxies, or shapes of galaxies that we're studying. So elliptical galaxies look like this, and this is an elliptical shape here, so that's what you're looking for when you're trying to figure out if it's an elliptical pattern or elliptical galaxy. Okay, they have very bright centers, you can see this here, but they have very little gas or dust, whereas the spiral ones have a lot of gas and dust. They can be elongated, and they contain only old stars, as well as no nebula. Okay, so they differ from the spiral galaxy. No nebula, and old stars, elongated, and very little gas and dust. And finally, the irregular galaxies looks like this. It's pretty irregular. There's no real definable shape. Okay, so no definite shape, contains very little mass. It has lots of gas and is made up of mostly young stars. And these two, like the spiral, contain nebula. All right, and so you may want to revisit this section of the video lesson with these bullet points when you're asked to compare some of the differences, either in a lesson review question or a test question, when you're asked to compare some of the differences between the three types of galaxies. that we're studying, all right? So you want to pay attention to older new stars. Does it contain gas and dust? A lot of it, a little bit? Does it have nebula or not? Does it have a lot of mass? You know, these are the characteristics that you want to focus on when you're studying and you're reading in your book. All right? So this is just showing you a general comparison of the 3 different types here, just side by side so you can see the differences between them. All right? And so for your homework, these are not lesson review questions. These are some critical thinking discussion questions. You can either answer these on a piece of paper and send me a picture of it, or you can just type them up on a Google Docs or a Word document and email them to me. And you can use your textbook as a resource as well as the rest of this video. So number 1, what holds binary stars in place? Number 2, why does the central bulge of a spiral galaxy appear redder? Number 3, what type of stars do elliptical galaxies contain? Number 4, what type of galaxy do astronomers believe the Milky Way is? And number 5, classify each of the following galaxies. And so you're going to use A, B, C, D, and E and tell me which one they are. Are they spiral, elliptical, or irregular? Okay? And you may, for number 4, it's your choice. It's in your book as well, but you may want to use an internet resource to look up the Milky Way to answer that question. All right? And so email those to me, and we will go over the answers to those in the next video lesson on Friday, May 8th. All right, and I will see you then. I hope you have a great rest of your week.